Hello everybody, welcome to your Section 9 Chem Talk. This is our last Chem Talk for Unit 1. So give yourself a pat on the back, you made it halfway through the course. So let's get started. At this point you should have your green sheet out and open to Section 9. The title for Section 9 is Organic Compounds and Combustion. Alright, so click the continue button when you are ready, and let's get going. So, ethylene. Also known as C2H4. It is a compound that has 2 carbons and 4 hydrogens. And this is the chemical responsible for ripening of our fruit. Right, so you can see as this banana, maybe you buy a banana at the grocery store that's green because you know you might not eat all of them right away. And ethylene is responsible for the banana going from green right, to a lighter green to a yellow, all the way until we are ready to eat the banana. All right. Ethylene is flammable, and that is why we tested different fruits for ethylene in our investigate. So if you noticed that white bright flame when you squeeze the ethylene gas out of your fruit, then we tested positive for ethylene. If not, it was probably still there, but in too small of a quantity for us to observe anything happening in the lab. Right. And ethylene is a compound that we would consider organic. Okay, now the definition for organic in chemistry class is going to be different than the definition for organic you might have heard at the grocery store. So be prepared to alter your definition of organic as we go through this. All right, so when we're talking about something as organic versus inorganic, let me move my face up here. There we go. So all molecules we can either consider organic or inorganic. Right? Inorganic just means not organic. There we go. So organic molecules is the largest area of study in chemistry. If you're interested in studying chemistry in a post-secondary academic setting, most chemistry majors have to take Chem 1 and Chem 2 in college, but then also organic Chem 1 and organic Chem 2. Right? So you're thinking about becoming a nurse or a doctor, or maybe a chemist or a chemistry teacher. Organic chemistry might be something you will study. When we talk about organic molecules in chemistry, these are molecules that contain the element carbon, right, with the symbol of C. Inorganic molecules, right, are mostly obtained through mineral resources, right? So maybe we're mining them, drilling in the ground in order to get them out. Right? And these molecules do not contain carbon. So your big takeaway here should be organic molecules contain the element carbon, while inorganic molecules do not contain the element carbon. All right, so let's go through this, and you have these examples written on your page as well. So I want you to classify the following molecules as organic or inorganic. And then check your work with the Ed puzzle and make any changes that you need. Very good. All right, so organic foods, right? There's a popular term going around there to maybe entice you to buy some healthier food. Now, in grocery stores, you see this all the time, organic foods. Not the same as what we're talking about today. So when we're talking about organic foods in the grocery store, these are foods that were grown or harvested without using any pesticides or fertilizers. Right? It's supposed to be as natural as possible. Right? And this is why they're more expensive. Right? If we're not using pesticides, then it's more likely that maybe bugs or animals might eat your harvest before it's ready. Not using fertilizer means it's harder for that food to grow nicely. So organic farmers have a lot of work to do in order to grow food at the same productivity as a typical farmer. Right? And there's a lot of hoops you have to go through in order to get your farm or garden labeled as an organic garden or farm. All right, but we do not use the term organic in this way. All right, so we need to separate these as two completely different things. Right, organic in the grocery store is not organic in chemistry class. So, talking about our organic molecules in chemistry class. Right, the simplest form of organic molecules is a group of compounds that we call hydrocarbons. Right, and by that name, hopefully you guessed, right, that it contains the elements hydrogen and carbon. Who would have thought? Okay. So some examples of this might be gasoline or kerosene, candle wax, propane. These are often things that we are able to combust, or things that we're able to light on fire. Right. The methane gas that we have coming out of our sinks in the chemistry lab would be another example of an organic molecule. And we'll actually talk specifically about methane later in this video. So, hydrocarbons are often used for fuels or sources of energy, right? That's why we can use a hydrocarbon, methane, to light our Bunsen burners, or to supply the fuel to produce a fire for our Bunsen burners. Right? And when we burn a hydrocarbon, right, in the presence of oxygen, we call it combustion. So basically, anytime something is burned or lit on fire, that substance is now reacting with oxygen in the air. Even though we can't see it because oxygen is an invisible gas, it is still a chemical reaction taking place. I'm sure you've heard that fire needs oxygen in order to thrive, right? But what's actually happening is that substance that's burning is reacting with oxygen. Right? And all combustion reactions will follow this pattern. Right? So your hydrocarbon will react with oxygen, and it will produce carbon dioxide and water. Right? You might think about a car. A car is a great example. So we might burn gasoline. That would be our hydrocarbon. And as we burn that gasoline, it's reacting with oxygen. So actually, the amount of exhaust that we release is more massive, or has more mass, than the fuel that we put into our gas tank. And that's because, right, our hydrocarbon is reacting with oxygen. So we're having another element added into our chemical reaction. Right? And then when you think about the exhaust of a car, you see a smoke come out. That's carbon dioxide. Right? And then sometimes, especially when it's cold outside, you might notice that there's some liquid dripping out of the exhaust, and that's water that has also been produced by the combustion reaction. Right? And we use combustion reactions because they release and create great amounts of energy. Right? We want to heat our homes or drive our automobiles. We need a combustion reaction in order for this to take place. Right? So for ethylene, the hydrocarbon that we use in our lab, the gas that came out of your fruit peels, right? This is what it would look like in a chemical reaction. Right, so we have ethylene, C2H4, reacting with oxygen, right? O2. Oxygen is a diatomic element, which means that it naturally occurs with two oxygen atoms bonded together, and they will produce or yield, that's what this arrow means, kind of like an equal sign in math class, except with a little bit more meaning to it, and it will produce carbon dioxide, CO2, plus water, and you should know that water is H2O. Right, so this is just an example of what a chemical formula would look like for this reaction. All right, so looking at some of our hydrocarbons, right, we call the ones that we're going to specifically focus on in this section alkanes. And these are hydrocarbons that only contain single bonds. All right, now looking down at the picture here, these lines connecting the C to the H, or the carbon to the hydrogen, represent our bond. That's the thing that's holding our atoms together. And when you see one line connecting two atoms, that is a single bond. If you see two lines connecting our atoms, that would be a double bond. And you might even sometimes see three lines connecting our atoms, and that would be a triple bond. So remember, alkanes, we only have single bonds. So you should only be seeing single lines when drawing your molecules. All right. And this is going to be below your pictures here. So alkanes have a general formula of CN, right, H2N plus 2. Right? That's kind of confusing at first, but I promise you it's pretty simple. So what this is saying is, depending on how many carbons you have, right, you will always have twice the amount of hydrogens plus 2. So let's take a look at some examples here. So right here we have one carbon. Oh, that would one carbon. So that our N would be 1, and now our H would be 2 times 1, right? Because we used 1 for the carbon plus 2. So 2 times 1 is 2, plus 2 for 4. So we have CH4, right? 1 C and 4 H's. Right? So however many carbons you have, that is your N number, right? So you can count how many C's you have in your molecule. And then in order to find how many H's you need, right, we need to double it, because that double comes from the H's above and below our carbons, and then that plus 2 at the end comes from our H's on the ends. Alrighty. There should be no carbons exposed. All carbons should be bonded to a hydrogen on all sides. Alright, so let's take a look here at 5 examples. So I have them lettered here. So A, right, B, C, D, and E. I want you to circle on your paper, right, which of these molecules, or I mean, there can be more than one, will we consider to be alkanes. Very good. So we are only looking for ones that have single bonds. So single bonds would have been what we were looking for. Alrighty. Now we're going to get into naming some alkanes. Alright, so you are going to be responsible for knowing all of the prefixes and the names of these 10 alkanes. Now, all of them, and we're going to make this easy, give you a nice mnemonic, a weird mnemonic device to help you memorize this. But so all of them will end with the letters A-N-E, right? So they will all sound like an alkane. So something ane is what they will be. So taking a look here, and you might need to pause this video in order to fill in your entire chart. So we have methane, right, with only 1 carbon, ethane with 2 carbons, propane with 3, butane with 4. All right, so these first 4, right, methane, ethane, propane, and butane, they do not get named by a numerical prefix, right? I'm going to be able to teach you 5 through 10 pretty easy, because the prefix just refers to how many carbons you have. But in order to remember the first 4, right, we want to look at their first letters. We have M, E, P, B. All right, so the best mnemonic device that your brilliant chemistry department could come up with is meth eats people's brains. I'm not kidding, okay? But it's one that should stick with you. So methane comes first, right? Begins with an M. Ethane from our eats, right, begins with an E. Peoples, right, or P for propane, and brains, or B for butane. So meth eats people's brains. That's how you can remember the first 4. And I'm sure some of these sound familiar to you, right? Methane is what we used in lab. Propane you might use for your grill. Butane is found in common household lighters. Now, our prefixes for pentane, hexane, heptane, octane, nonane, and decane all come from, right, our numbers. So pent, or a pentagram, is shaped with 5 sides. So a alkane with 5 carbons would be pentane. Right? Object with 6 sides would be a hexagon. So an alkane with 6 carbons would be a hexane. And that's going to be the same for, right, heptane, hept meaning 7, oct meaning 8, non or nana meaning 9, and dec or deca meaning 10. Okay, so make sure you have those all filled in, and you should have these memorized. So if you need to make some flashcards in order to help you, that might be a good idea. Alrighty, so that's going to end our Section 9 Chem Talk. Make sure you are also completing the Chem to Go after you finish this video. Have a good day.